Dear visitors, as the Managing Director of NIMAK GmbH, I would also like to welcome you on behalf of the whole team of NIMAK GmbH. Welcome to Wissen. In the next 2 to 3 minutes, I would like to talk a little bit about projection welding. Together with Mr. Röder, our head of development, I would like to talk about what we can do today in CD welding, in projection welding. Now, projection welding as such is a process that is widely used if we want to have these fasteners and put them onto sheet parts. It can be rivets, it can be bolts and nuts, but it can also be larger structures such as strut elements or other designs which can be put onto the sheet metal. As a long-established processes, you normally have MF welding, medium frequency, up to 80 kiloampere currents. When it is about smaller to medium-sized components, or if it's about larger structures and fasteners, such as for the strut design, you have capacitor-discharge welding. Both processes have their pros and cons. With this machine engineering, we can combine the benefits of the two processes. The classic capacitor-discharge welding has the benefit that you have low input current, but you have a disadvantage that you have a very steep rise, a high peak welding current, which during the welding cannot be controlled. Quite in contrast, in MF welding, you have the benefits that you have a completely controlled process. During the whole welding, I can always control the current, and I can really run welding profiles. Now, with this new performance technology, we've been able to combine the two benefits of the two processes in order to resolve very challenging problems. In order to show you what performance technology we've used, Mr. Röders will now open the box for you, open the wire cabinet, and will show you the inverter technology. Mr. Röder, could you open the cabinet for us, please? Okay, this is one of various converters that we use, and on top of that we have the input converter supplying DC current. The converter for joining technology feeds pulses up to 50 milliseconds up to various seconds, and it's completely variable. It's also highly energy efficient, so the losses in the converter, but also in the other components of the system, have been optimized and minimized. So in the transformer converter, but also in the secondary circuit of the system, it's been optimized. Another novelty of this system is that we have this transformer which is supplied with DC, and DC is the up-and-coming technology for industrial operations. We no longer work with three-phase AC, but we will have DC used in the future. And in this project, in this technology, we're already using this. Okay, and we can now have a look at the example of a welding process. Okay, in order to show you the most important parameters of this machine, we can have welding currents completely controlled during for all profile types up to 200 kiloamperes. On top of that, we have magneticDRIVE technology used here, which is a highly dynamic actuator on a magnetic base, which means that during the actual welding, the welding force that we need for the repositioning of projection welding can be controlled at any time and adjusted. And based on these control parameters, welding force and welding current that are completely controllable, we can use very challenging tasks. One of the current tasks that we've been confronted with most recently from electric mobility is the connection between copper parts and aluminium parts. And if you know a little about metallurgy, you know that both materials are highly electrically conductive and also very good heat conductors. So inputting the process energy during the welding is a very challenging task. Now, with this system, we have been able to keep the welding energy in the welding spot based on the process control with the two parameters, force and current. Mr. Röder, can you show us the welding process, please? Unfortunately, it's not very spectacular, but nevertheless, I wanted to show you that we've got a very firm welding bond between the aluminium and the copper part. Development partners of Bochum University, Faculty of Material Sciences, who have co-developed and co-studied this with us, they have shown in high-performance vibration testing that the connection between aluminium and copper and the intermetallic phases that you normally have that make the material brittle have been more or less avoided by this process technology, so that we have evidence that with good process technology and engineering, you can also do projection welding with these sophisticated tasks. Well, dear visitors, I would like to welcome you here in person. Come and see us. Mr. Röder and his team, our engineers, are always looking forward to customers coming to us here into the technology process with their challenging task. And I think we're very well prepared for resolving these tasks for you. Thank you very much.